Okay, a few comments on the take-home quiz. Here it is, block date, Thursday, October 31st, year 2019. What is this? 502 years to the day since Martin Luther nailed his 95 Theses to the Wittenberg door. 502. A long time ago. A lot has changed since then. On the take-home quiz, you had to describe a simulation. Now, when you're describing the simulation, you're basically giving directions to people who are going to figure out what to do based on your words. So, in your scheme, you have to have referred to either a random digit table. Those of you who did that, for the free throw shooter, you probably did 0 through 71. It means you made a shot, and 72 through 99 means you missed. Others of you said 01 through 72 means you made the foul shot, and 00 and 73 through 99 means you missed. But you can't say, go to your random digit table and pick a random number from 1 to 100, or a 2-digit number from 1 to 100, because 100 is not a 2-digit number. So some of you lost a point on the take-home quiz because you thought that 100, or you referred to 100, you included it in the group of 2-digit numbers. No, if you're going to say select a 2-digit number, you say, well, it's going to be from 00 to 99. And also, the 2-digit number thing, yeah, you had the freedom of doing either this or that for the 2-digit number. You have to put specific phrases in there, like start in the upper left-hand corner, select random digits, 2 at a time. So basically it's things to do. You can use random digit table, you can use a calculator to select your digits, and then say, well, we're going to use random integer 1 comma 100. We're going to scoop them up 3 at a time. Actually, there's no point in doing 3 at a time. You can just do 2 at a time, because you would never need 3, because repeats are okay. Because what if the first number you scoop up is a 49? If you're saying that 1 to 72 is you made a shot, then 49 means you made the foul shot. And if you scoop up a 49 again, that's okay. That means you made it again. So in this case, we don't ignore repeats. Some of you said ignore repeats, and you lost a point for that. Ignoring repeats is not needed in this situation. The other option that is sometimes used is a hat. So you could say, write the integers from 1 to 100 on an individual slip of paper, put them into a hat, shake the hat, and then pick one number. If that one number happens to be from 1 to 72, that corresponds to making a shot. And then here's where the non-replacement rule came from. Replacement has to do with hats. If you pick out a number, let's say you pick out slip number 49, then do you put it back into the hat? Do you replace the number? Yeah, you put it back in. So the whole non-replacement rule traditionally, that's used only when you're talking about putting numbers into a hat and picking from a hat. Because you don't have to talk about replacement with a random digit table. You don't put the number back into the random digit table. You don't have to put the number, replace it into the calculator. No. Once the calculator spits out a number, you don't ever try to put it back in. Have you ever tried to put a number back into a calculator? Like you put a number into a hat? Right, it doesn't make any sense. The non-replacement rule is only in the context of hats. But basically you give people directions, do things, and then you have to put in a stopping rule. And I gave you an example of how to do this, and a lot of you followed the example from the AP test, but you had to say, well, we're going to stop, and there was a 3-part rule. If the first number is not 1 to 72, then stop. If the first number is 1 to 72, but the second number is not 1 to 72, then stop. But if the first number is 1 to 72 and the second number is 1 to 72, then stop. So it was a 3-part stopping rule. You have to give people directions so they know what to do. so that two people who are knowledgeable in statistics would end up doing the same thing if they read your directions that you wrote out on the practice or on the take-home quiz. And then there also had to be some sort of, now, in the old days they called it count. These days we're more likely to call it a response variable. It's like, okay, so we do all these things. What are we looking for? What do we end up writing down for each trial? What we end up writing down is, you say, record the number of free throws, not attempted, but free throws made. And that will be either 0, 1, or 2. So you end up writing down, here's a response variable. It's the number of free throws made. Why is it variable? Because it's not always the same number. It's not constant. It could be either 0, 1, or 2. It truly is a variable. It's what we end up counting, what we pay attention to. How many did they make? Either 0, 1, or 2. So you need a scheme, a stopping rule, and then also what to do with repeats. And you could put what to do with repeats right here in the scheme. You could say, do not ignore repeats. Somebody said ignore repeats, but you could say, do not ignore repeats. So if you first draw a 49, and the second one is 49, then that's okay. It's okay to have two 49s in this situation. We've seen simulation situations in which you're not allowed to have repeats. So you gotta be thinking through what should be the clear directions so that people really end up simulating what happens at the free throw line. Any questions on the take-home quiz? Okay, people did pretty well on the take-home quiz. Some people bombed it. I decided to put a cushion of 4 on it so the lowest you could get was a 4. Even if you got a 0, I bumped it up to a 4. It's called the cushioning practice, which we do on all tests. Not all quizzes. Most quizzes are cushioned. But Jack Lichty gave me permission to hand out his paper because he got them all right. So if you're wondering, man, how did Jack Lichty get them? If you want to see the Jack Lichty version he gave me permission. So I'm going to hand out 2 per row. If you want to keep, you can. You don't have to. But you can take it, look at it. If you don't want it, just return it to me. Or actually, just pass it all the way back and collect them on the desk in the back. If you don't care about looking at the Jack Lichty sheet. So this stuff is for you to keep. And Sam shows us. Where's Sam went? Is he hiding somewhere? Does anyone see Sam? Is he like under a desk? Or Sam? Or Sam, come on, get out of there. Sam, I am. He says Sherry's absent. Sherry's actually here. Even though you got called out, that means a lot to me. All right.
The glasses on.
Well, wow, the camera's still going. So let's continue. I want to let you know what's going on today. Today we're taking a quiz, which I call a practice quiz. So you'll take the quiz. I'll give you an idea of what Monday's real quiz is about. So Monday's quiz will be 20 points graded individually, and then 1 week from today is the Unit 4 test. I have a practice test I'll be handing out tomorrow. So make sure you get a hold of that practice test. Today we're taking a practice quiz, and we also have to finish up the notes for this unit. So I think today will be the last day of new material, and maybe we'll do statistics in the news tomorrow. Might feel like new material, so let's do the sample surveys part 1 to 4. It took us 2 days to get this far. Now we're going to finish the rest of the packet in 1 day. It's kind of amazing. It is a block day, but we are going to start cruising. Here we go. So we are on problem 1, Roper. Yep. So I'm just going to pause the camera. We're back. So in this problem, through their Roper reports, GfK Roper conducts a global consumer survey to help multinational companies understand different consumer attitudes throughout the world within 30 countries. Researchers interview 1,000 people aged 13 to 65. Their samples are designed so that they get, and this is an always thing, they always get 500 males and 500 females in every sample. And that's in all 30 countries, so a total of 30,000 people participate. Are they using a simple random sample? Is this an SRS? So what do you think? Katie?
No.
Why do you think the answer is no?
Wait. Yes.
The answer, according to Katie, is yes. So this is actually a great time to review what a simple random sample is. The definition of a simple random sample is that each subgroup of size 1,000 is equally likely to be selected. So size n. In this case, lowercase n is 1,000. So is it really true that every subgroup of people in this country, consumer attitudes, so is every subgroup of 1,000 equally likely to be selected? Like, how about one of those subgroups that has 1,000 guys in it? Because there are 1,000 guys in this country. There's a lot more than that. Is that as equally likely to be selected as, let's say, maybe, 500 males and 500 females? Katie? It's a yes or no question.
Yes.
The answer is no, because it's impossible. It's impossible to get a sample of size 1,000. It's impossible because of the design. It's designed to never get 1,000 males. So it's not simple. It's not a simple random sample. If it were a simple random sample, then every subgroup of size 1,000 would be equally likely. You wouldn't have any groups, you wouldn't have any subgroups that are impossible. But because of the design, here's where they gave you the hint that it's not a simple random sample. If it were, then getting a sample of 498 males and 502 females, and another sample of 500 males, 500 females, and then another sample of 500 males and 500 females, and then some other sample of only 1 male and 999 females, they would all be equally likely. But because of the design of this survey, those are impossible. They have probability 0. And 0 is not the same thing as the probability of a particular subgroup of 500 males and a particular subgroup of 500 females. That's, for any particular subgroup of 500 males and females, it's unlikely, but it's not 0. It is at least possible. Small but non-zero is not equal to 0. So that's why Roper is not using a simple random sample. The samples are designed to get 500 males and 500 females. And that, there's actually a mistake in this official solution. So cross off these words and cross off those words. Here's what actually should be written here. And before I write this down, is there a question on this?
Yeah, you said what is impossible to get?
It's impossible for this survey scheme to generate 1,000 males and 0 females.
Oh.
If it were a simple random sample, then getting 1,000 males and 0 females, or at least 1,000, and then actually list the names of those 1,000 males. So a particular subgroup of 1,000 males would be equally likely as getting a particular 500 set of 500 males and a particular set of 500 females. Because every subgroup of size 1,000 is equally unlikely, but they're unlikely, but they have the same probability. But they're non-zero probabilities. The problem is with this scheme, you'll never get a probability of, or you'll never get 1,000 males because they decide they're just never going to do that. It's impossible if you follow the scheme. So here's what we should say. The samples are designed to get 500 males and 500 females. So since they're asking about a simple random sample, our explanation should demonstrate that we know this statement. So a sample of 1,000 males is impossible. Comma, or has 0 probability. Comma, according to this scheme. In an SRS, each subgroup, we could say, had this been an SRS, that's a better phrase. Had this been an SRS, had this been an SRS, each subgroup of size 1,000 would have been equally likely. So whenever they ask about whether or not something is an SRS, refer to the definition of an SRS. Okay. So what kind of sampling, what design, what strategy are they using? Just scan through the options at the top of the page. If it's not an SRS, what is it? Raise your hand if you're reasonably sure you have a guess on this. You're reasonably sure that you have a correct guess. It's not an SRS. Val? Yeah, in a stratified sample, you take the entire population, and that is one thing we learned yesterday, and that is that we view the group that we're trying to tell a story about, either the true mean or the true proportion. We call them a population. Did we have the sampling frame category the last time you were in class? Did you see that? Okay, so sampling frame is a subgroup of the population that we hope is representative of the population. And then the sample is a subgroup of the sampling frame, and that's what we're actually getting our statistics from. So the sample gives us either our X bar or our P hat, and it will help hopefully be representative of the true population proportion P or the true population mean mu. So P and mu are the parameters that represent the population. X bar and P hat are the statistics. The nice thing about this, friends, I'm glad this is being recorded, because I haven't said this yet, but it's easy to remember. Population is represented by a parameter. P goes with P. Samples give us statistics, S with S. So samples give us either X bar or P hat, the statistics, and populations have either a true proportion P or a true mean mu. Parameters go with the population, statistics come from the sample. All right. So, yeah, they are using a stratified sample. So we're taking the entire population and dividing it into strata, and then we're taking a random sample from each stratum. They are using stratified sampling. And we're using two strata. Those strata are males and females. Emoticons. I don't use emoticons a lot when I'm texting. When I do, sometimes I select them at random. I use a random emoticon selector. As my daughter, who's in my 5th period class, can attest, yesterday I sent her, she was asked about doing something after school. She said, "Dad, I've got all my homework done." And so I replied with an emoticon of a football. Kind of random. Which she used to find funny, but now it's like, wow, Dad, that got really old really fast. Random emoticons are not the way that I recommend that you conduct yourselves. But the website www.gamefaqs.com asked, as our question of the day, to which visitors to the site were invited to respond, please respond to our survey. Do you ever use emoticons when you type online? 87,000 people responded. 27% of these strange people said they don't use emoticons. What kind of sample is this?
Convenience sample.
Yeah, this is a sample that better watch out because it's about to be thrown into the fire. This is a convenience sample. You can say this is a convenience sample. Now you could also get full credit by saying, because it's very convenient to say, please respond to our survey, because we don't have to take the time to say, Well, let's assign each visitor to our website an integer. And then let's put each integer on a sheet of paper and put all the slips of paper into a hat. That's not convenient. That takes a lot of work if you're doing thousands and thousands of slips of paper. So anyway, we also focus in on the word invited to respond. Why is it convenience? Because we're asking for volunteers. So we can say it's a convenience sample, or you can get full credit for saying this is a volunteer response sample. Voluntary response. Subject to volunteer response bias. So how much confidence would you place in using 27% as your estimate of, see that's, by the way, 27%, that's a p hat, proportion means percentage, p hat. The estimate, the fraction of people who use emoticons is a parameter p. So the statistic comes from the sample, the parameter describes the population. We want to know in our population what fraction of people use emoticons, and we have absolutely no confidence. Put it in all caps because you're screaming. Absolutely no confidence. In estimates made from voluntary response. Any questions on number 3? All right, let's go to the next page. Problem 5. Let's hope. Eventually get to the next page. At its website, the Gallup poll publishes results of a new survey each day. Scroll down to the end, you see the fine print. You'll find a statement that includes this. Results are based on telephone interviews with 1,008 national adults. Okay, so back in 2007, the phone landscape was different. Most people had landlines, and so when Gallup was polling people, instead of using random digit dialing, which could pull up my cell phone right now, I mean, Gallup could call me right now on my phone, using random digit dialing. Back in the day, they didn't go for cell phones. They didn't use random digits as their sampling frame. They used the phone book, and people had landlines. They didn't even say they had landlines. Telephone interviews, it was assumed that they were landline telephone interviews because it seemed like it would be invasive to call people's cell phone at random. So, for this survey, identify the population of interest. Now, once they say population of interest, they're talking about 3 circles. Population, which is described by a parameter, the sampling frame, and the sample. And you have to be good with the English language to precisely describe who's in the population and who's out. Sampling frame, who's in and out. The sample, who's in and who's out. So this is a real exercise in using the English language. So let's jump in at this level right here. So, population of interest is all adults in the United States age 18 and older. Notice it's to say it's adults. The population of interest is adults. That would give you an I. It's not an E, it's not a P. That'd be an I. Because you didn't have the word all. It's all adults. But if you just said all adults, that would be a P. It's like all adults in the galaxy, all adults that happen to be in Antarctica right now? No, it's all adults in the United States. Mr. Royce, it doesn't say we're in the United States. That's what brings some people to tears in this course. It's like, you have to think about what the context is, even though they don't tell you. If they don't tell you that it's other countries, assume it's the United States. So this is tricky. Describing where is that, who's in my population, who's out. It's all adults in the United States age 18 and older. Now they want to know what's the sampling frame. So, okay, we've got the outer circle, that's a population. What's the sampling frame? Well, it's not all adults in the United States age 18 and older. It's only people who have landlines. Because from 2007, they were not calling cell phones, they were calling landlines. These telephone problems are challenging for we AP instructors to write because we have to be aware of the telephone landscape and be very precise about whether mobile phone users are in the sampling frame, or is it just people who have a landline, or what's going on there? So in this case, back in 2007, it was US adults with landline telephones. Now, what problems, if any, would show up? You matching the sampling frame with the population. I mean, ideally, the sampling frame will match the population. Were you here, Wynna, when we were talking about tasting the soup?
Yes.
Yeah, you were. So we want the sampling frame to have the same taste as the population. Any problems here? Well, back in 2007, like when I went to Wheaton College, we had phones in our rooms. So if my parents were gonna call me, my parents lived up in Wisconsin. If they're gonna call me, I have to plan it so that I'm in my dorm room when they call. Well, if Gallup is gonna call a college student, back when I was in college, it's very unlikely that a college student would ever answer their phone. College students, back in 1980 when I went to college, basically meant you are retreating from civilization for 4 years. You never find out who wins the World Series, who the president is, or if a president resigns. You wouldn't know because you're out of touch, you're isolated. These days, people are more connected with what's going on in the World Series and with who's the president of the United States and when they resign. So back then, the college students weren't included in the surveys, so they could never be chosen in the sample. That could create bias, that could throw things off. Learning targets on the bottom. Any questions on this particular page? These are the things, by the way, you're supposed to be learning. Learning targets. Last call for questions on this page. All right, let's go to the next one. We are cruising through this packet. Oh my goodness. Here we go. Hello? Okay. So suppose this was your homework question. The homework that's due tomorrow, by the way, is the National Hockey League problem. You have the handout. You have to describe how you're going to do a survey. Different types of surveys. Let's look at problem 7. Consumers Union asked all subscribers whether they had used alternative medical treatments, like acupuncture. And if you did poke yourself with needles, did that help? Did that benefit you? Do you feel better now? That's what this survey was about. Alternate medical treatments. For almost all the treatments, approximately 20% of those responding reported, yeah, I feel much better now. Or at least I feel, substantial improvement. So what's the population? All US adults. See if you can fill in the other ones. Try to fill in the other. Oh, is that one all filled in for you? So that one's filled in as an example, so you have an idea. Let's see if there's any mistakes here. Yeah, go ahead.
How do you know it's all US adults?
No. Well, you have to put yourself in their shoes. Consumers Union wants to know, basically go out as far as you can with your population without leaving the country unless you have a passport to leave the country. Okay? So they want to know what's going on with US adults. They're Consumers Union. It doesn't say it's a US publication, but if it doesn't say international, we're going to say, okay, we're in the United States, we're going to say it's US adults. But look at the sampling frame. Going for the whole country, but we're not. Our sampling frame is only their subscribers. They're only asking their subscribers. So that could be a big problem because their subscribers, people who, it may be a representative of the population, maybe not. But it says they only ask their subscribers. So it's very common for there to be a difference between the sampling frame and the population. Now the sample is those who answer the survey. And the method was not specified, but it does say that they asked all their subscribers. So they probably maybe sent a questionnaire, or emailed them the questionnaire. Snail mail, email, not sure. Bias. Okay, you're gonna get a lot of non-response bias, specifically voluntary response bias. This is the main thing to focus on. Is look, they weren't randomly selected. If they're randomly selected, then you can, it's like a manageable number of people. You email them, you text them, you send men dressed in black to their front door who say in the gentlest of tones, it's time to complete your survey. You get a really good response rate when people show up at your door. Those who respond may have strong feelings one way or the other. So you try the one on the bottom of the page. Why do these chips taste funny? A company packaging snack foods. And you know what, let's make this more interesting. Let's make this a company. We'll call them Snicky Snack Foods, okay? Sounds appetizing. Snicky Snack Foods. Packaging snack foods. Maintains quality control by randomly selecting 10 cases from each day's production and weighing the bags. Then they open one bag from each case and inspect the contents. Should be a D in the word and. That's what my parents always taught me. Try number 13 on your own. Pause the camera, and then we'll see how you did. Welcome back. Okay. Now, be very skeptical here. Population. Snack food bags. Nope. Why is that not the correct answer? Might get you a P, but not an E. What would it take to get an E on this? Okay, Bill.
All the snack food bags.
So all snack food bags that were produced by Nabisco from the year 1800 to the year 1925, or all snack food bags made by all companies in all of human history. We have to draw the line carefully on the population. So, the company's social. It's not enough to say all snack food bags. We need the word all in there. We need all snack food bags produced by Nabisco. No, all snack food bags produced by, if I hadn't said Snicky Snack Foods, I would have had to say by this company. But since I said, I specified the company, all snack food bags produced by Snicky Snack Foods. In one day? Well, no, they're quality control, they're probably concerned, all of them, not just in one day. Sometimes you have to give a time frame, but there's no time frame given here. So what we care about is not just today, we care about all the days, but we don't care about the other companies, we only care about our company. So draw the population circle specifically enough so that every snack food bag knows, am I in the circle or am I included or exclusive or excluded? Snack food bags typically like to be included in these invasive inspections. What's the parameter? The parameter, whenever you see the word parameter, you know they're going to be asking either for the word proportion or the word mean. And here I'd accept either one. I don't care whether you use proportion or mean. It could be the proportion passing inspection, because they do say they inspect the contents. Proportion, we should be a little more specific. Proportion of the. Proportion of bags of snack foods passing inspection. I think would be better. This would be an E minus. Proportion of bags of snacks passing inspection. What's the other possible word you could have in answer to a question about what's the parameter? Mean is the other one. So it could be, since they do weigh the bags, maybe the parameter, I would give full credit, so would College Board, they would give full credit if you said the mean weight of all snack bags. Bags of snacks. So they could be going for the mean, they could be going for the proportion. But if you don't have the word mean and you don't have the word proportion, you're getting an I on this one. Next, sampling frame. Now, all produced each day, so it's not all bags produced. The sampling frame is all bags produced in each day. Those are fair game for this inspection. If you are a snack bag who was produced yesterday, then you're off the hook. You're not going to be inspected. The sampling frame is only the bags that were produced today. That's Snicky Snack Foods. The sample is 10 bags, one from each of 10 randomly selected cases. So, yeah. So if you read carefully, you say, well, the sample, there's just 10 bags in the sample. So you've got to be able to describe. Know English well enough to know how to describe the population, the sampling frame, and then the actual sample. Be specific. Method. Multi-stage sampling, presuming the leads, simple random sample of 10 cases, followed by a simple random sample of 1 bag from each case. Yeah, they take an SRS twice. There's no special name for that, so they just did 2 steps, and there's no special name for taking an SRS followed by an SRS. Which, by the way, looks like a good plan. There's no indication that we're going to be off target here, no indication of bias. So it's time for the practice quiz. I'd like you to do problems 1 through 6 on this practice quiz. And if you're taking this practice quiz at home, here, take a screenshot of this. Wait, take a screenshot of this, questions 1 through 5. Select, click. Now take a screenshot of question 6. There it is. You got it. So I'm going to pause the camera, and it's the Texas A&M University problem. Okay, so question 1, the population of interest is a 46,000 member Texas A&M University student body. Any questions on that one? Who thinks they can describe the population parameter of interest? I'll take a volunteer on this. I'll let you know whether it would be an E or an I. Will, go ahead.
Proportion of students who were first in their family to attend Texas or to attend college.
Okay, so I heard you use the word proportion, and you can use either the word percentage or proportion. They are synonymous. I like proportion better though. The population parameter of interest is the proportion of students at the school who are the first in their family to attend college, which sounds like exactly what you said. Thank you, Will. Any questions on that one? Okay. The sampling frame. Has anyone picked up on the sampling frame? Who's pretty sure they don't know what the sampling frame is? Who thinks that maybe they do know what the sampling frame is? Does anyone want to give this a go? The sampling frame is going to be different than the population. It's, Jed, do you want to try it?
Sure. One dorm building at Texas A&M University.
And that's what someone said in my 5th grade class. Someone said just one dorm building. It's all the dorm buildings. The sampling frame is all the dorm buildings, or students. In fact, they're actually not asking dorms. Are you the first dorm in your family? Dorms actually don't even go to college. Dorms exist at colleges, but dorms have never been born. They're built by people who have been born. So you gotta be careful. The sampling frame is actually students who live, oh wow, so that's a mistake. That's a mistake right here. Who live in, not the chosen dorm, in any dorm on campus. So some students would get full credit on this if they said students who live in on-campus housing, assuming that all on-campus housing is dormitories. If that's true, you can say that. But the sampling frame, can someone explain to me why the sampling frame is not the same as the 46,000 member student body? Why is the sampling frame as described here, Texas A&M students that live in any dorm on campus, why is that not the same as the population? What's the difference between the sampling frame and the population in this case? Katie?
Some students can live off campus.
Some students live off campus. They're not in the sampling frame even though they're in the population. Nice. People, you're getting this. I can tell. It's not easy. It's usually not until you fail on a few of these practice quiz questions that you really learn. Here we go. What's the sample? Who's got that one? Grant, you wanna give that one a go?
I said sample is the one dorm chosen and every student inside that one dorm chosen.
Yeah, so careful. Don't say the sample is a dorm, it's the students in each room of the selected dorm that were sampled, yeah. So be specific. What are we talking about? People or buildings? We're talking about people. Likewise, a sampling method. Does anyone have a sampling method that they think is being used here? What method are they using? You can look at the list of all the sampling methods. Back to Graham.
Is it a cluster sample?
So a cluster sample, we'd know it was a cluster sample if they said they randomly selected. It says they went to each room in one of the dorms. How did you select that dorm, administrators? Did you select it just out of convenience? Like, oh, there's a dorm. It's snowing outside. I don't want to walk very far. Let's just go to that dorm over there. It's close. They didn't tell us. So if they said, well, they're administrators, they're trained in statistics, they probably didn't do one of those convenience samples. They're getting paid big time. They wouldn't make that kind of mistake. So they're probably, if you said cluster sample, if you said convenience sample because it was just convenient to walk over there, then you would get full credit for either one of those two. Because there was a mini census involved. They took a census of everyone in the dorm. So that's the kind of thing that indicates they might have been doing a cluster sample. So full credit for that. And then suggest a reason why the results might not be generalized. Just one reason. There's a lot of reasons why this might not be generalized. Results might not be generalized population interest because sampling method is exposed to several forms of bias. There might be undercoverage bias because there's a lot of people that don't live in dorms, so we're not even asking them. Further, there might be a convenience bias in sampling from one dorm because we don't know whether they really did an official random selection of the cluster. For example, if the dorm primarily houses athletes, so this is actually a third issue. What if that dorm primarily houses athletes, non-athletes are undercovered? Sometimes it's those athletes who are like, yeah, there's a long tradition of students going to Texas A&M and playing football. That's what our family does. So this one dorm, maybe one of those dorms that's not representative. For some reason, it always seems to come back to football. Well, you have a Tom Brady jersey on there. I saw a story yesterday that Tom Brady might end up playing for the Los Angeles Chargers next year. Did you hear that?
I didn't hear that, but I heard that people think he might be leaving.
Might be leaving. Yeah, he might have to buy a new jersey.
Because his house is for sale. And different stuff like that.
Tom Brady's house is for sale?
Should buy it.
I hadn't thought of that. It never even crossed my mind. So you said it. And so now I'm gonna start thinking about that. I wonder how much it costs. Okay, so now the backside of this quiz, if you want to, I would recommend you do this before Monday. Do the backside before Monday. But for now, we're gonna change gears and look at the notes. I think we're on 5.2 now. Are we on the part of the notes that has the targets? So you'll want to watch this part of the video. We're at the 44-minute mark. 44-minute mark on the video, okay? Okay. So, mistaken poll. I need a volunteer who's willing to read problem 15, starting at a local TV station down to explain out loud for our group. Anyone willing to read problem 15? Kind of fun fact, yeah. Who would like to read number 15? You guys want to read it in unison on camera?
Yes.
Yes.
You can, if you want, you can come up here, bring your paper, and you can just stand next to each other and read it right into the camera.
Do it.
You wanna do that?
Let's do it, Will.
Come on, guys.
No, all right.
Come on. So ladies and gentlemen, this is Will and Graham reading problem 15. If you stand back a little bit,
Obnoxiously
then your
close.
faces will be lighted. So
But what if they wanna see us?
Yeah, they wanna see his face. I don't
you
blame him.
guys do it. You guys go for it, however it is you want to do it.
3, 2, 1. A local TV station conducted a pulse poll about the upcoming mayoral election. Evening news viewers were invited to phone in their votes, with the results to be announced on the late night news. Based on the phone calls, the station predicted that Amamo would win the election with 52% of the vote. They were wrong. Amamo lost, getting only
Amabo.
46%
Amabo,
of the
let's get it
vote.
right. Amabo.
Do you think this state?
Amabo?
Oh, Will, we gotta start over here. All right, okay.
Start with, they were wrong.
They were wrong. Amabo lost, getting only 46% of the vote. Do you think the station's faulty prediction is more likely to be a result of bias or sampling error? Explain.
Yes, give me a hand, thanks guys, way to go. Okay, and let's see, was the camera on? Yes, it was even on, okay, so we're up to the 46. Yeah, it was on the whole time.
I thought it was.
Oh, we have to start over.
Back up.
And, poor Chad, he feels excluded from population, students, they're learning statistics. Come on in, Chad, another person, okay, wow, you are really gonna wanna go back and watch it. That, you're gonna be, that's
Yes.
not what you would expect. Okay, well, friends, the first thing that seems a little strange here is that this is a book, a stats book, the yellow one, it's copyright 2004. In 2004, they put in this problem containing Amabo, which is Obama spelled backwards. Obama did not become president until the year 2008. What's Amabo doing in a book that has a copyright of 2004? This is nuts. Maybe maybe all the future presidents are somehow weirdly included in our stats book if you just read it really carefully. Amabo would win the election. Okay, so, well, they were wrong. Ooh, I didn't see that before. That's interesting. Really? Is this what yours says? Does it have all this yes, no stuff on it?
Jail.
Good. Well, it's more like this. Okay, so first of all, yeah, let's analyze this. Station's faulty predictions more likely should be the result of bias. You see, only people watching the news were able to respond. I used to watch the news when I was a kid. My parents, our whole family would come together at 10 o'clock at night. We would sit down and watch the news. It'd be half an hour, it'd be 30 minutes. The first 8 minutes was some guy reading the news, and then commercial break. And then the next 8 minutes was a weatherman telling what the weather's gonna be. And then there's a commercial break, and then the sports report came out. You found out who won the World Series. You could see the highlights of most recent times if the Bears lost a game. And it was all right there, right on the evening news. So, but here, hardly anyone watches the news anymore. Raise your hand if, like, that's a regular part of your life, is sitting down at 10 o'clock and watching the news together as a family. No one has their hands up. It's just not a thing anymore. So anyway, people are watching the news. Even back in 2004, it was a different subgroup of people who watched the news, and their opinions were likely to be different from those of other voters. Sampling method may have been systematically produced samples. So the sampling method may have systematically preferred a particular outcome, or systematically favored a particular outcome. An outcome that did not represent the population of interest. To illustrate the problem, okay, so let's take a look at the targets. Bias is bad. We're going to look at two words, bias and error. Notice those are the words that are featured in our curriculum. Bias and error are words right out of our AP Stats textbook. To understand bias and error, I'd like you to consider two words that you probably are much more familiar with, and those words are accuracy and precision. Accuracy and precision are words that are usually much more accessible to statistics newcomers. I don't know if you consider yourself a statistics newcomer, but you are. So, accuracy and precision. I have a nephew who got married last summer. Back when he was in high school, he ended up majoring in mathematics. Back when he was in high school, my nephew, Jonathan, said, who was not dating at the time, he said, I don't want to date, but when I do date, I don't want to date now, but when I do date, I'm going to select a woman with accuracy and precision. Didn't want to mess around like dating 12 different people. No, I'm going to date with accuracy and precision. And you know what he did? He ended up dating just one person. Her name's Kara. Who knows, maybe she's watching now on YouTube. Hi, Kara. Hi, Jonathan. And your Uncle Neil is teaching statistics today, talking about you. And sure enough, they got married. They got married last summer. He dated only one person. They got married. Best I can tell, they're happily married. So, live on the East Coast. Yes. So he selected a woman with accuracy and precision. Well, you can also bring accuracy and precision into the sport of archery. Now, suppose someone is very accurate in shooting an arrow, and the first arrow that comes in, it's a bullseye, and then they take aim again. Bullseye, bullseye. That's an example of someone who has both accuracy and precision. So no bias. If there's no bias, that's something that you might be more able to apprehend as a beginner as saying, there's accurate. Someone is accurate. If there's no bias in their shooting of bows and arrows, then they're accurate. But the other thing we see in this diagram is no error. That's a statistics term. No error means more accessibly they're precise in their shooting. So they're accurate and precise, which means they're accurate, it always hits the bullseye. Precise meaning every time they shoot, it's like precise. It's one thing to be accurate, but kind of accidentally. I want to show you a picture of what it would mean to be accurate but not precise. So let's draw another target over here. Because accurate and precise are not official statistics words, but they're much more accessible. You need to learn the words bias and error. So what would it mean to have no bias but yes error? Or error but no bias. So instead of saying yes error, which is kind of an awkward thing to say, I'm just going to say error, which means not no error. Error but no bias. What would it look like if someone who was an archer had no bias but some error? Well, I'll tell you what it would look like. It would look like this. Oh, you missed. You're biased. Maybe you hit the bullseye sometimes. But if you look at the average of all your shots, it's accurate. So it's not biased. Just that there's some errors. I mean, there's a non-zero standard deviation in there, essentially. So error is measured in standard deviations. So here's a picture of what we mean by accurate but not precise. People in archery can imagine a shooter who is accurate. You're accurate. You're not precise, but you're at least going in, on average, you're hitting the bullseye. Accurate, not precise. Precise. Okay. Can someone imagine what what the pattern would be on the bullseye or on the target if someone had yes bias, if they're biased in their shooting, but there's no error. So they're yes on bias, but no on error, meaning that they are not accurate. You are not accurate in your shooting, but you are, no error means you're precise. Is there anyone who's willing to come up here, take the stylus, and put a pattern of yellow marks on the bullseye that would represent a shooter who's not accurate but precise? Okay, Will, come on up. This is Will's second. This is Act 2 of Will in this video, which so here we go. This is Will Casto demonstrating. Look at that. See what he's doing? That's way to go. You did it. It's not accurate. It's not accurate, but it is precise. Statistically, we would say we have bias, but no error. Now, this is all in the context of surveys. Like you can have a survey saying, well, what percent are going to vote for Amado? And they get 52%. Next survey, 52%. Next survey, 52%. It's like, wow, it's precise. It's not accurate, so it's biased, but there's no error, which means there's no difference from survey to survey. So sometimes surveys are like that. Actually, well, no, actually they're not. Surveys are not like that. Usually you get a scatter shot of results from one day you give a survey, maybe you'll come into DuPage County and you give 20 different surveys, and every survey would be a little bit different. But hopefully the average of all the survey results would give you the truth. So this is really what we're shooting for in statistics. We want no bias. We're fine with error. We just don't want bias. So, oh, it's so precise, there's no error. Big deal. It's not accurate. It's biased. Bias is always bad. And then, of course, you can imagine, in fact, would you go ahead and draw the bullseye that would represent in our metaphor not accurate and not precise, which means it's biased and there's error. Biased and error. So try to put a pattern. Let's see. Yes bias and yes on error. Yes bias means not accurate. And yes error means not precise. So not accurate and not precise. And you probably already see it in your imagination. Oops, what happened there? Okay, so you're probably seeing this. The center of the pattern is not on the bullseye and it's scattered about. So this is what we're shooting for in terms of creating surveys. We don't want bias, we're fine with error. Okay, parent opinion, part 1. We're down to number, 17? In a large city school system with 20 elementary schools, the school board is considering the adoption of a new policy that would require elementary students to pass a test in order to be promoted to the next grade. Are you kidding me? You can't go to 3rd grade until you pass the 2nd grade test. Who would ever do this to another human being? It's cruel. The PTA wants to find out whether parents agree with this plan. Oh boy, get ready. Listed below are some of the ideas proposed for gathering data. For each, indicate what kind of sampling strategy is involved and what, if any, biases might result. Okay, let's put a big ad in the newspaper asking people to log their opinions on the PTA website. Ooh, we're using the internet. Oh, this should work. No, that's a voluntary response sample. Lots of problems. Only those who see the ad will feel strongly about the issue. And that. I mean, they've got to not only feel strongly about the issue, but they've also got to have web access. Who has web access? Anyway, that's a lot to expect. Randomly select, okay, here's a plan B. Randomly select one of the elementary schools and contact every parent by phone. Okay, so what kind of sample is that? Sorry. Well, wait, you might be right. I just didn't hear you.
SRS.
SRS? Okay, if it were an SRS, then every subgroup of size n would be equally likely to be selected. But if they're randomly selecting, so then if you can imagine a subgroup where there's like, 10 people from one school and 40 people from another school, that would be impossible because they're just, every member in the sample, every parent is from the same school. So that's how we know it's not an SRS, okay? I mean, if it were an SRS, we'd say, let's get everyone in the whole school district, all 20 schools, let's put them together on one list, assign a number to every person in the entire district, all 20 schools, and then go get a random digit table and select digits 3 at a time, because actually probably 4 at a time, because you probably, there's probably more than 1,000. So select them 4 at a time, and then talk about how the number you pick corresponds to the number of the parent on the list. Now this is a cluster sample. So if you know your sampling strategies, you know that they randomly selected a cluster. Here, every school is a cluster, and then they took a census of everyone in that cluster. It's probably not a good idea, though. The opinions of parents in one school may not be typical or representative. Typical is an okay word, but I would rather use the word representative of the opinions of all parents. Any questions on that one? Okay, let's flip the page again. So flipping over to the next page. Hello. So, now what's going on? Here, I have an idea. Let's send a survey home with every student and ask the parents to fill it out and return it the next day. Like that's gonna work. Here, take the survey, put it in your backpack, take it home, and when you get home, open your backpack and take the survey out and then track down your parents and ask them to do something? Are you kidding me? No one will ever do this. You're attempting to take a census using children as key instruments in this. So, wow, whoever thought this was a good idea, they'll probably suffer from no one's gonna do this. No one as in air quotes, no one un-air quotes. Randomly select 20 parents from each elementary school. Send them a survey, follow up with a phone call, a text message, an email, a landline call, and send 3 men dressed in black to their door if they don't return the survey within a week. See, now these people actually want to get both non-bias, they're fine with error, but they don't want bias. They want it to be representative. This is stratified sampling, by the way, because we're getting 20 from each school. Now, it's not necessarily proportional, so it's not necessarily an ideal stratified sample unless every school has the same number of parents, probably doesn't, but it's still stratified sampling. If the follow-up is carried out carefully, the sample should be unbiased. We should hit the bullseye on this, or at least close to the bullseye, so if we did it several times, on average, we'd be able to average them out. The errors would cancel, and we'd get a good idea of what's going on in the churches. For your political science class, you'd like to take a survey from a sample of all Catholic churches members in your city. A list of churches shows 17 Catholic churches within the city limits. Rather than try to obtain a list of all the members of all the churches, you decide to pick 3 churches at random. And then for these churches, you'll ask to get a list of all the current members and contact 100 members at random. What kind of design is this? Tell a shoulder partner what kind of design you think this is. Go ahead, don't be shy. Tell them what kind of sample it is. Someone who is at either your left or right shoulder.
What do you
It's
think,
okay.
Garrett?
It's okay, you're still.
It seems like a cluster, like some.
Yeah, it does seem like some sort of variation. The problem is a cluster sample. Okay, so someone said it seems like a cluster sample. And problem is that in a cluster sample, you have to take a mini census of everyone in the cluster, or every subject or unit in the cluster selected. So because there's no census of these 3, we can say it's multi-stage. So, and it says we have a cluster sample at the first stage, which is actually not even true. That's a misuse of cluster sample. It's actually a simple random sample at the first stage, because we took a simple random sample of 3 churches, and then we took a simple random sample again of 100 people. So it's double SRS. It's multi-stage. You can't really say it's a cluster sample unless a census is involved of the selected clusters. So, what could go wrong with your design if any of the 3 churches you pick at random are not representative? Okay, so that's always the issue with sampling. What if it's not representative? That could go wrong, then your sample will reflect the makeup of the church. Not all churches also choosing 100 members at random from each church could introduce bias. The views of the members of smaller churches chosen in the sample might be weighted heavier. Heavier. It's a new word. Heavier contains the letter I. In your sample, then the views of members of the larger churches, especially the views of the members of that small church, differ from the views of the churchgoers at large. Okay, hope is that random sampling, and there is a lot of hope to have with random sampling. The hope is that random sampling will equalize these sources of variability in the long run. That's a powerful statement in terms of your concept development. So it's not guaranteed that this is a bad idea, because randomization solves a lot of these problems that popped into someone's imagination. You're saying, oh no, it's not gonna be that way. Hold on, we did randomize. So that should take care of it. Let's go to the next page. There is no next page, so no, but there is. Don't you have like part 3 of 3? I would like you to quiz yourself. On the next page, would you please, from memory, list the 6 sampling strategies and reds. Okay, but on yours they're blank. So list them from memory. List them without looking. If you saw that, go ahead and erase that from your mind. Yep, everything's going just fine here today at Wheat Academy. Yeah, just a reminder, the National Hockey League problem is due tomorrow. That's paper submission. Have a good day.